Hello, good afternoon, everyone. I am here today to take a session on rigid body dynamics and center of mass, and it's a very interesting topic, and it is having a lot of application in different topics of physics. Correct. So join fast, and if someone is there online, then you can tell me, am I audible? Am I visible clearly? Am I audible clearly? Just a quick message from your side will help me to start the session. So we'll start it without wasting your time. Right. So I'm just starting now, and the people can join in between. So as the title suggests, that the topic is system of particle and rotational motion. So I'll be considering both the topics today. I'll be doing the analysis for center of mass as well as rotational motion. So I'm just mentioning the topics here. So center of mass, then rotational motion. Those subtopics that I'll be covering here is angular momentum conservation, angular momentum and its conservation, moment of inertia and torque, writing the moment of inertia of a body and writing the torque, then writing the angular momentum and its conservation. These are some topics. And in center of mass also, I'll be dealing with few concepts. So this is like how I am planning this topic for today's session. So I'm just going to cover up the very important part, because in 1 hour the entire chapter cannot be completed. So I'll be just taking up the few important topics. I'll be giving a glimpse that these few topics are very, very important, and you have to go through those concepts. When you are practicing questions, you can just go through those topics, revise those topics in details, and you can practice questions on this kind of format, okay? So moving ahead. Just a minute. I'll take up some empty slides. So first, when I talk about center of mass, so we have to think what is this point and what is the use of this point, why we are doing center of mass, or what is the use of this particular concept. Otherwise, where we are lagging, what was the difference when we are not using the concept of center of mass and when we are using the concept of center of mass. So it is like center of mass is what? It is the point. It is the point inside or outside the body, okay? So the center of mass of a body can lie on the body, or it can lie outside the body. It's not important, it's not mandatory that center of mass of the body should lie on the body itself. So center of mass of the body can lie on the body, or it can lie outside the body also, okay? So the point it can lie inside or outside of the body, and at this point the whole mass of the body, can be supposed to be concentrated. to be concentrated. It's a simple statement written in English that it is a point where I can assume the entire mass of the body is concentrated, right? So let's say I'm having this random shaped body and it is having let's say mass of 50 kg. So this 50 kg mass is divided throughout this body, okay? Because there will be some particle, here will be some particle, here will be some particle, here is also some particle, here is also some particle, here is also some particle. So when these all particles are combined together, the entire mass becomes 50 kg. Okay? So to make the mass of the body to 50 kg, every particle is contributing a small mass. Every particle is contributing a small mass. So when we add the total mass of the body, it comes out to be 50 kg. Now, for this body, there will be a point where I can assume that the entire mass is concentrated there. So let's say I am assuming randomly here that this is the center of mass of the body. I am saying this is the center of mass of the body. So it means that I can assume that now this body is replaced by only a point mass, that green color dot I have made here, because I am saying that this particle, this point is the center of mass. So for this entire body which is randomly distributed throughout this volume, I am saying that this point is center of mass. So it means now this entire mass can supposed to be concentrated here. So now the mass is same. The body was having the total mass to be 50 kg, and in this scenario also I am having the total mass is 50 kg, but now that 50 kg mass is not distributed in a volume. That 50 kg mass is concentrated only at this point. So now we have just only one point. Now we don't have the entire body. Now we don't have any volume. Now we don't have any area, or we don't have any length. The entire mass is concentrated only at this point. So this point is center of mass of the body. So where the center of mass of the body will lie, or how to calculate the position of the center of mass, that we'll discuss later on. But you should have this idea that center of mass is such a beautiful concept by which we can replace the entire body. We can replace the entire body with only a point mass. And in the past topics we have already covered how to deal the motion of a point mass. Like in kinematics also, in NLM also, in work energy power also, we have never ever considered the dimension of the body. Whatever it was written that a car is moving, or a scooter is moving, or a cycle is moving, in all the situations we are not considering the dimension of the cycle, or we are not worried about the dimensions of the car. We are only considering that car is, let's say, 1000 kg mass, so that 1000 kg mass is represented on a point mass. So by default we are considering everything to be a point mass. But now when we have to consider the dimension of the body, so dealing with a definite size body which is having a proper size, proper area, proper volume, will be difficult for us sometimes. So in such scenario, whenever possible, we'll try to replace that entire body with a single point mass, and that single point mass which is equivalent for that given body will be known as the center of mass of that body. So now this problem statement will convert into simple situation like when we are dealing with only one point object. So now this entire body is replaced by a point object which is having the same mass, and it will be located somewhere. So location is not a problem, we'll learn how to calculate that. But this is a concept by which we can convert a given problem statement where we are having a definite size body into a point size body. So this is the concept of center of mass, and as I told you, it can lie inside or outside of the body. So we'll try to take some symmetrical situations, and we'll try to figure out the center of mass of those bodies, and later on we'll apply those concepts in problem statements. So now I'm discussing how to locate the center of mass of the body. So let's say ki I am having a body, right? I am having a body on which large number of particles will be lying. So here a large number of particles are lying. So I'm taking one reference point. I'm taking one reference point, and I'm assuming that this particle is having the position vector as r1 vector, and this is another particle which is having position vector as r2 vector, and so on. This is going to be having a large number of particles. So this is r3 vector. So like this is having infinite number of particles, okay? So when I have to write down the center of mass of this kind of system, I'll be writing m1 r1 vector plus m2 into r2 vector plus m3 into r3 vector, and so on, m4 into r4 vector, and so on, divided by the total mass of the body, m1 plus m2 plus m3, and so on. And this will give you the position vector of the center of mass. I hope this is clear. This idea is this simple. So we have to write down. So these are like mass multiplied by its position vector. So this is known as mass moment. So what I am doing here is I am adding the mass moment of each particle. So this particle is having mass m1 and its position vector is r1. So m1 r1 vector is the mass moment of this particular particle. This is the mass moment of the second particle. So when I am adding the mass moment of all the particles and divided by the total mass, so I am getting the position of the center of mass. So this is simple. So in general, we are most of the times required to apply this concept only for two particle system, generally two particle system or three particle system. So it's not like that important for us, like we are applying it for how many number of particles. It's just simply a calculation. The calculation will get longer and longer. So to understand the idea completely, applying on a two particle system is sufficient. We can learn, we can understand the concept by applying this concept only to a two particle system. So if I am applying this simple concept to two particle system, so again RCM vector will be given as m1 into r1 vector plus m2 into r2 vector divided by the total mass m1 plus m2. Okay. So when I am writing this, so I am getting position vector like this. Okay. Now if you understand from here, very strategically we can take this reference point. This is the reference point from where I am taking all the position vectors. So I can take a reference point to be anywhere. Okay, I can take reference point to be anywhere. That is our choice. So suppose in some situation I am taking reference point as at the point of center of mass of the body. Like in this situation, this was the center of mass of the body, and if I choose this as my reference point, that this is the origin, this is 0 0. So in such scenario, what will happen? When I am writing the center of mass of the body, it is m1 r1 vector plus m2 r2 vector divided by m1 plus m2, and that is equals to your RCM vector. And I am assuming that wherever the center of mass of this body is lying, I am considering that point to be the origin. So this RCM vector will become 0, right? It's 0. So in such situation, I am getting m1 r1 vector plus m2 r2 vector equals to 0. When I am considering center of mass to be at origin. So when center of mass is lying at origin, this will become 0 0, and this m1 r1 plus m2 r2 will become 0. So from here I get idea that m1 r1 vector equals to minus of m2 r2 vector. So from here I can see that r1 vector and r2 vector are opposite in direction, and the distance will also be different. So like if I am having a two particle system, I am replacing here. Let's say I am having these two particles like m1 and m2. then the center of mass will lie somewhere between these two masses, and let's say this is the center of mass. So obviously this is the center of mass. So I have taken center of mass to be at origin 0, 0, and the position vector of the first particle, is this one. This is r1 vector, and the position vector of the second particle, is this one. This is r2 vector. So are you getting the point? What I was saying is, r1 vector and r2 vector are opposite in direction. You can see this is r1 vector and this is r2 vector. So both of them are in opposite in direction. So if we know the total length, we can also get r1 and r2 individually. So this is like how we can obtain the location of the center of mass of two particle system, or if the number of particles are greater than 2, then also we can also obtain the center of mass. So again, if I write down this vector in form of I cap, j cap and k cap, also I can find out the x, y and z coordinate of the center of mass. I'll show you how to write down that. So simply only I am just equating the x component, y component and z component, so you will understand it when I am writing RCM vector. So this is m1 into r1 vector plus m2 into r2 vector divided by m1 plus m2. Now I am assuming that this r1 vector is having x1 I cap plus y1 j cap plus z1 k cap. This vector is this one. So r1 is what? R1 vector is x1 I cap plus y1 j cap plus z1 k cap, and I am taking r2 vector to be x2 I cap plus y2 j cap plus some z2 k cap, and I am writing this RCM vector to be xCM I cap plus yCM j cap plus zCM k cap. I have written these vectors in form of x, y and z. You know that we can write down any vector in form of x, y and z component. So this vector is x1 I cap plus y1 j cap plus z1 k cap. Similarly r2 and RCM vector I have written. Now I am just putting the values of this r1, r2 and RCM vector here in the equation. So what I am getting here is, xCM I cap plus yCM j cap plus zCM k cap, okay, and the right side I can say m1 multiplied by r1 vector. This r1 vector is x1 I cap plus y1 j cap plus z1 k cap. Are you following me? And you will see that this is very simple. Just I am writing the vectors and just I am equating them. So you don't have to mug up these results. When you try to mug up these results, it becomes difficult. But when you try to understand this becomes very simple. So again, m2 multiplied by r2 is this one, x2 I cap plus y2 j cap plus z2 k cap divided by m1 plus m2. Now what I am doing is, I'll compare the coefficient of I cap in both the side. I'll compare the coefficient of j cap on both the side. I'll compare the coefficient of k cap on both the sides. Because if these two have to be equal, then their I cap, j cap and k cap coefficient should be equal. So just comparing them, what I'm getting here is, one term is m1 x1, the other term is m2 x2, and both are having the coefficients of I cap, right? So m1 x1 plus m2 x2 divided by m1 plus m2, that should be equals to xCM. So comparing, I am getting xCM equals to what? m1 x1 plus m2 x2 divided by m1 plus m2. Similarly, that yCM is what? m2 x2 m2 y2 actually. This is m1 y1 plus m2 y2 divided by m1 plus m2. Now you can see that what the coefficient of k cap. In the left side, the coefficient of k cap is zCM. So I am writing z center of mass, and then here I am getting m1 z1, and here it is m2 z2. m1 z1 plus m2 z2 divided by m1 plus m2. So now we have got the coordinates of the center of mass. We have got the coordinates of the center of mass, and earlier I was getting the position vector of the center of mass. So if I am getting the position vector of the center of mass, definitely I can also get the coordinates of the center of mass. So just understanding this concept, I am applying these concepts. Okay. So I am taking up an example. Let's say, okay, this is some straight line and some particles are located over here. Okay, this particle is located at some 2, 0 point. This is located at some 4, 0 point, and this is located at 8, 0 point. Here the mass is 1 kg, here the mass is 2 kg, here the mass is 3 kg. Okay. So I have to find out the center of mass of this 3 particle system. 1, 2 and 3 particles are placed on a straight line having mass 1 kg, 2 kg and 3 kg, and their coordinates of the location are given as 2, 0, 4, 0 and 8, 0. And for this situation I have to find out the center of mass. So as I told you, first you have to write down one point where you are taking the reference point. Okay. So I am taking my reference to be at origin. Let's say this point is origin. I am again telling you that to select a reference point is your choice. There is no condition on that. You can choose any point to be your reference point. But again, you have to be very smart enough to choose your reference point, because choosing a good reference point will ease your calculation. Otherwise, your calculation can get lengthy. So with practice, you will understand that which point you should choose so that your calculation becomes simple. So with time you will get this idea. So currently I am getting this point to be here. Okay, I am taking this point to be here 0, 0. Now I am writing the center of mass location. So let's say I don't know where the center of mass is located. So I am assuming that center of mass is lying somewhere here. Okay, and this length from here is x. So obviously from my situation, the center of mass will be located at some x, 0. I am assuming like this. It's not mandatory that I have assumed the correct situation. It may be wrong also, but I have assumed. This is my assumption. The center of mass is lying somewhere here. And why I have chosen here? Because center of mass generally reside toward the heavier side. So here if I can see here 1 kg, 2 kg and 3 kg. So 2 and 3, this is 5 kg. So this is the heavier side of the system. So center of mass should lie towards the heavier side. So this is general idea we have. So center of mass will lie toward the heavier side. Understood this point? So I am having the center of mass assuming to be lying here at x, 0. So now I know that in order to find out the x coordinate of the center of mass, what I have to write down? m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. So mass of the first body is 1 and its x coordinate from here is what? 2 plus 2 multiplied by 4 plus 3 multiplied by 8. So I have written m1 x1 plus m2 x2 plus m3 x3 divided by the total mass. This is 3 plus 2, 5 plus 1 is 6. So this is 2, this is 8, this is 24 divided by 6. So 8 plus 2 is 10, 10 plus 24 is 34, 34 divided by 6. So this is 17 by 3. This is 17 by 3. So you can understand 17 by 3 is 5 point something. But it should be greater than 4. So it should be greater than 4. So my assumption was correct. My assumption was correct. Because I had this idea that the center of mass is going to lie toward the heavier side. So from this situation I can sense this thing that this is the heavier side of the system. So center of mass should lie this way. Okay, because 2 kg and 3 kg are lying this side. And here only 1 kg particle was lying. So definitely the center of mass should be lying in this side. And that is true from my calculation, that it is coming to be 17 by 3. So the center of mass is lying at a distance of 17 by 3 from your reference point. From here it is 17 by 3. Now I'll show you different version also, so that you get a better idea. So I'll show you one more thing, that in order to solve this question, I have three particles lying at 2, 0, lying at 4, 0, and lying at 8, 0. Okay, and this is lying 1 kg particle here, and here 2 kg particle is lying, and here 3 kg particle is lying here. Okay, now just see here, I am changing my reference point. As I told you earlier, that you can choose any point to be your reference point, there is no problem. So this time I am choosing my reference point to be here. Okay, now I am choosing, this is my reference point. This is my reference point. Okay, so if I am choosing this as my reference point, so again I have to write down the location of the center of mass. Okay, so this time I will be getting the location of center of mass from this point. Okay, remember this thing. Now if I am taking this as my reference point, then this is my new location, and this point is located at a distance 4 in this side, and this is located at distance 2 in the left side. Okay, so what I am going to write down is, center of mass position is again m1x1 plus m2x2 divided by m1 plus m2. So if I am taking this as my reference point, so for some instant consider it to be 0, 0, and this will become 4, 0. I am just taking this as the positive side, and now I am considering this to be negative side, and this particle is located at 2 units from this point, so it should be minus 2, 0 according to my reference point, new reference point. If I was taking this as reference point, this was my result. If I am taking this as my reference point, so for a moment I will consider this to be 0, 0, and with respect to this point, this will be at 4, 0, and this will be at minus 2, 0, because I am not changing this distance. Okay, this distance is 4 units, so it should be 4, 0. This distance is 2, and this is toward the left side, so this should be minus 2, 0. Now I will be writing m1x1. Okay, m1x1. So what is the mass? This one 2, and its position is what? 0. So can you see this thing? In previous situation, there were total 3 terms. Okay, but now one term is multiplied by 0. This term is going to vanish. This term will become 0, na? And then this is 3 multiplied by 4. Okay, this is 3 multiplied by 4, and this is 1 multiplied by minus 2, and this is divided by the total mass, that is 6. So from here this will become 0. 4 into 3 is 12. 12 minus 2 is divided by, it is coming to be 10 by 6. So my answer is what? 5 by 3. My answer is 5 by 3. So this distance of center of mass is 5 by 3 positive, right? It is positive 5 by 3. So from here, the distance of the center of mass will be in the positive side, and it will be distance is 5 by 3. So from here, this is your center of mass, and this distance is 5 by 3. I hope this is clear. I hope this is clear. Now, I can also get this result from my previous result. Okay, because I know that from here the distance of the center of mass was this one, 17 by 3, and from here to here the distance was 4. So if I have to calculate this distance, I can simply do what? I'll take this distance 17 by 3 minus this distance is 4. So you can see this result is 17 minus 12 by 3, and this is 5 by 3. So you can see that both the results are correct. So initially I told you that you can choose your point, any point to be your reference point. There is no problem in that. Just like if you will change your reference point, your answer for center of mass will be calculated from your reference point. So the answers will be different from different reference point, but ultimately all the answers are same. Because here I was calculating the center of mass from this point 0, 0, so I was getting 17 by 3. But when I am calculating the center of mass from this point, this will not be 17 by 3, right? It will be 17 by 3 minus 4. So 17 by 3 minus 4 is 5 by 3, and I have done it using a different approach. So both answers matches, and whatever I was trying to teach you, and I'm really hopeful that you would have understood this point. So this is the entire idea about the center of mass. Very easily you can write down all these things. Coming next, so if you can write down the center of mass of any body, any particle, if you are having n number of particles in a given system, still you can write down the center of mass of all the bodies, right? So let's say I was having the center of mass like this as m1 x1 plus m2 x2, and then divided by the total mass of the body. So let's say if the center of mass is displaced by some distance, if the center of mass is displaced by some distance, then what will happen? So I'm just going to write down the differential things here. So let's say the slight change in the position of the center of mass is dxcm, and this will be m1 dx1, and this will be m2 dx2 upon m1 plus m2. So if you change the positions, of mass m1 and m2, definitely the center of mass location will also change. So let's say you have displaced this x1 particle, first particle m1 particle, by a small amount dx1, and you have displaced the second particle m2 by a small amount dx2. Then the change in the position of center of mass will be what? dxcm. And how you can see how they are related. This is dxcm equals to m1 into dx1 plus m2 into dx2 divided by m1 plus m2. So the idea is very simple. That if you differentiate this entire equation with respect to t, then dxcm by dt equals to m1 into dx1 by dt plus m2 into dx2 by dt divided by m1 plus m2. So displacing these particles m1 and m2 will also displace the position of center of mass. But what they sometimes ask, the problem statement is that if m1 is displaced by certain amount, then by what amount m2 should be displaced so that the center of mass remains at the same position. So if the center of mass remains at the same position, it means that there is no change in the position of center of mass. So in that case dxcm will become what? It will become 0. So if I am saying if center of mass does not shift, so in that case dxcm will be what? It will be equals to 0. So putting that here, what I am getting here is m1 dx1 plus m2 dx2 equals to 0, right? m1 dx1 plus m2 dx2 should be equals to 0. Are you getting this point? So if center of mass is not shifting anywhere, then m1 into shift in the position of the first particle plus m2 into shift in the position of the second particle should be equals to 0. So let's discuss a problem here, that if I'm having two particles, one is having 6 kg mass and other one is having 2 kg mass. So initially they are having some position of the center of mass. I don't know where the center of mass is exactly lying, but 6 kg and 2 kg masses are placed here. So 6 kg is also point mass, 2 kg is also a point mass, okay. So their center of mass will be lying somewhere. And now we have been asked that if 6 kg mass is displaced by 15 centimeter towards right, then by what amount 2 kg mass should be displaced so that the center of mass remains at the same position. So as we have seen here, that if the center of mass does not shift anywhere, it remains at the same position, then dxm should be equals to 0. So m1 dx1 plus m2 dx2 should be equals to 0. So I am going to apply this concept here. So the mass of the first particle is 6 kg and its displacement, I am taking this to be the positive side. So 6 into the change in the position of the first particle is 15. 6 into positive 15 plus, now I don't know by what amount this have to be displaced, so I'm just writing 2 multiplied by x, and that have to be 0. That have to be what? That have to be 0. So just solving this equation, what I'm getting here is 6 into 15 equals to minus 2x. So from here I'm getting x equals to 6 into 15 divided by 2 with a negative sign. So 2 in this is 3 and this is minus 45. So if it is displaced by 15 centimeter toward the right side, then this 2 kg mass should be displaced by a length of 45 centimeter toward the left side. Because this was displaced in the positive side, and we are getting that this should be displaced in a negative side, and the amount is 45. So I hope you are able to understand this concept. It's an easy concept. So this was like how we can calculate the center of mass of 2 particle, 3 particle system. And similarly, for given some shapes, the center of mass location is given that you can remember it. So directly you can use the center of mass. So for generally, like if we are having a ring, for ring the center of mass lies at the center, geometric center. For disc also, if it is a disc, the center of mass will lie at the geometrical center. And then if we are having a sphere, then the center of mass will lie at the geometrical center. So when a body is symmetrical and it is of uniform mass density, then the center of mass generally lies at the geometrical center of the body. In different cases, the center of masses, you can see some data will be given in your textbooks or the books you are following. So you can just go and remember that results. So directly you can use those results in your numerical problems. So again, coming to the next point, I'll look up few questions. If we can solve few questions directly from. Okay, I'll tell you one more concept. So we know that the center of mass position is written like this: m1 x1 plus m2 x2 divided by m1 plus m2. If I differentiate this equation with respect to t both sides, so what I'm getting here is it will be dxcm by dt, and this is m1 multiplied by dx1 by dt plus m2 multiplied by dx2 by dt divided by m1 plus. So this is what? Rate of change of position of center of mass. This will be velocity, right? This will become velocity of center of mass, vcm, and this is m1 multiplied by v1. This is m2 multiplied by v2 divided by the total mass of the body, that is m1 plus m2. So if we can write down the position of the center of mass correctly, then differentiating that equation we can also get the velocity of center of mass, and that is m1 v1 plus m2 v2 divided by m1 plus m2. And if I differentiate this equation one more time, so what I'm getting here is d in vcm by dt equals to m1 is constant, right? So it is taken outside the differentiation, and this is dv1 by dt. Then this is m2 multiplied by dv2 by dt, and this is m1 plus m2. So what I'm getting here is, what is the rate of change of velocity vector? Rate of change of velocity vector is acceleration, and we are differentiating the velocity vector of center of mass. So I'm getting the acceleration of center of mass, and this is m1 into a1 plus m2 into a2 divided by m1 plus m2. And you have to be very cautious writing these things, because these are the coordinates, right? These are the coordinates. So you have to be very cautious writing the positive and negative things, because if it is a positive coordinate or it is a negative coordinate, you have to accordingly write down the signs. And as you are writing the signs, accordingly you will also get the signs. So always make a habit writing in terms of vector form. That will be very easy. So when you are writing in vector form, directly you will be writing m1 x1 vector plus m2 x2 vector. Similarly here also, this is m1 v1 vector plus m2 v2 vector. So you will be getting velocity of center of mass in vector form. So if it is positive or if it is negative, accordingly you will get the result. Otherwise what will happen, if you are not writing them in the vector form or you are not writing them with a proper sign convention, then the acceleration, again you have to write down the proper sign convention. You have to use proper sign or you have to use the proper vector form, then you will get the correct acceleration. Otherwise you can end up doing a mistake. So you have to be very cautious when you are writing the directions. If you are not writing the signs, then you will get a 0. You will get a negative marks, right? Not 0. You will get a -1. Instead of getting +4, you will end up getting -5. 4 is gone and then you are losing 1 marks. So you are losing ultimately 5 marks. Okay. So you don't have to do this. Don't do negative. Negative is very dangerous. So m1 a1 plus m2 a2 upon m1 plus m2. This is how we can write down the velocity vector of center of mass, acceleration vector of center of mass, to find the center of mass, all these things. Now coming to the question. Now you can see here, it has been asked that two particles A and B initially at rest. Two particles are there and they are initially at rest and they are moving towards each other under the mutual force of attraction. So I am saying that there are two particles A and B and they are initially at rest. So its velocity is 0, its velocity is also 0. So velocity of A is 0 and velocity of B is also 0. And now they move towards each other under the mutual force of attraction. So they are having some mutual force of attraction that can be a gravitational force, or if they are charged bodies, then it can also be a electrostatic force. So due to their mutual forces, they are moving towards each other, and then they are saying at an instant when the speed of A is v and the speed of B is 3v, then what is the speed of the center of mass? You have to find out the speed of the center of mass at the instant when the speed of A is v and the speed of B is 3v. Just I am giving you a quick 5 seconds of time, just think of it and tell me the answer. You will be getting a very interesting solution for this. So if you have done it, I'll tell you the solution for this one. Okay. So initially you can think that if the center of mass is, if the velocity of the first particle is 0, velocity of the first particle is 0. So what is the velocity of center of mass initially? Initially, it is mass of the first particle into velocity of the first particle, that is 0. Mass of the second particle into velocity of the second particle 0 upon ma plus mb. So VCM was 0 initially. So if the velocity of center of mass was 0 initially, and since there is no external force on the system, right? F external on the system is 0. So if the net force on the system is 0, initially the center of mass was at rest, then will not it remain at rest according to the Newton's first law? Newton's first law states that anything which is in some state of motion will remain in its state of motion until and unless there is a net external force acting on it. So there is no external force acting on the system. So center of mass was at 0 speed. So it will remain at 0 speed. So what is the correct answer? The correct answer is 0. Interesting, right? Yeah. So whenever, so this is learning from here. If F external equal on the system is 0, if F external on the system is 0, then velocity of center of mass will remain constant. Acceleration of center of mass will be 0. These are two important learnings that we are having from here, from this particular question. If there is no external force on the system, if it is written like this, they are moving because of mutual force of interaction. So what is their mutual force of attraction? This is an internal force. If I am considering this to be a system, so the force acting here and the force acting on B in this direction, these two are internal forces for this system. So the mutual force of attraction, the mutual force of repulsion, these are the internal forces if I am considering this to be a system. So for my system, this is an internal force. So F external is 0. F external is 0, so VCM will be constant and acceleration of center of mass will be 0. Good to go from here. So moving ahead with the next question. If you are loving this session, please do give a thumbs up so that I get more energy for doing such kind of sessions for you people. So now let's look at this question. Two objects of mass 10 kg and 20 kg respectively are connected to the two ends of a rigid rod of length 10 meter. So if I'm having a rod of length, 10 meter and 10 kg and 20 kg are respectively connected to the two ends. So let's say 10 kg is connected here and 20 kg is connected at this point. So 10 kg and 20 kg masses are connected to the two ends of a 10 meter long rod, and the rod is having negligible mass. So we don't have to consider the mass of the rod, okay? So the distance of the center of mass of the system from the 10 kg mass is. So they are asking us to find out the center of mass of the system from 10 kg mass, okay? So as I told you earlier, whenever we have to find out the center of mass of any system, first we have to choose a reference point. So in this case, I am going to choose this 10 kg as my reference point, okay? This is 0, 0. I can choose any point as my reference point, as I told you earlier. So I am choosing this point to be your reference point. And why I am doing this? Because if I will be taking my reference point from somewhere here in between these 2 points, then then first one particle is lying toward the left side, one is lying toward the right side. So for some masses I have to write down the positive distance, for some masses I have to write down the negative distance. Then the second thing is that directly we have been asked to find out the distance from 10 meter. We have been asked to find out the distance from the 10 meter. So I have to, if suppose from here I am getting the center of mass, so I will have to calculate this distance. In case when I am taking this, I am taking the reference point to be at one of the masses, so directly one term will become 0, so directly I will be getting the answer, okay? Calculation will become simple. And why not I am choosing this as my reference point? Because if I will be choosing this as my reference point, so let's say I am getting some distance x from here. So center of mass is at x distance from here. So from here we have to find out the distance 10 minus x. So we need to do one more step, because the distance have been asked from 10 kg mass. So if I am taking this as reference point, so my center of mass will be at x distance from here, but they are asking from here. So this entire distance is 10, this is x, so we have to calculate 10 minus x. So I am not doing that. So I am choosing this as my reference point, and from here directly I will get the center of mass. So very wisely you have to choose your reference point. There is no condition, but wherever you are choosing your reference point, be wise, be smart. So in this case, the center of mass will be 10 multiplied by 0 plus 20 multiplied by 10. I am taking this to be positive direction. Divided by total mass is 20 plus 10 is 30. This term becomes 0. So 20 into 10 divided by 30. So this is 20 by 3. So from here the location of the center of mass is somewhere here, okay? This is the center of mass and the distance is 20 by 3. The distance is 20 by 3 meter. So straight away I have got the answer. 20 by 3 is 6 point something. 6 point something, and it should be. Why? Because the center of mass should lie toward the heavier side. So 20 is the heavier side. So center of mass 10 kg and 20 kg are located at 10 meter distance. So if both the masses would have been equal, this is 10, this is 10, so the center of mass would be at 5. okay, exactly at the midpoint. But since this is heavier, it has got shifted like this. So it should be greater than 5. So answer is 6 point something 20/3. C is the correct option. C for Chennai is the correct answer, okay. C for Chennai is the correct answer. Shall we move to the next question? Yes. Okay. Now see this question. Three identical spheres. We have three identical spheres, each of mass m, are placed at the corners of a right angle triangle with mutually perpendicular sides equal to 2 meter. See the figure. Taking the point of intersection of the two mutually perpendicular sides at the origin, find the position vector of the center of mass. Okay. So basically, like, this was the right angle triangle. This was the right angle triangle. I'll draw it once. So one sphere was lying here, one sphere was lying here, and one sphere was lying here, like this. Okay. So three identical spheres, each of mass m, are placed at the corners of a right angle triangle. So one sphere is at this corner, one sphere is at this corner, one sphere is at this corner. So with mutually perpendicular sides equal to 2 meter. This is 2 meter and this is 2 meter. And taking the point of intersection, this and this line are intersecting at this point. So this is the point of intersection of the two mutually perpendicular sides at the origin. And this question they have given that you have to take this point as origin. So now we cannot choose any point as origin. We have to follow the instruction of the paper maker. Okay, the question paper maker has given us instruction that you have to choose this point as your origin. Okay, no problem, I'll do that. Now what they are asking, find the position vector of the center of mass. Oh, that is not a problem. That is not at all a problem. Very easily I can write down the position vector of the center of mass. So we know that the position vector of center of mass is what? M1 R1 vector plus M2 R2 vector plus M3 R3 vector divided by total mass M1 plus M2 plus M3. Okay. There are total 3 particles. Okay. So for 3 particles I have taken 3 terms, M1 R1, M2 R2 and M3 R3 divided by the total mass. Now I am assuming this to be my first particle. This is my first particle, this is second particle, this is third particle. So first particle is lying itself at the origin. So this term will become 0, right? Now I'll be writing second particle and third particle. So now writing the second particle, its mass is m, and what is the position vector? This is 2, and that from here this direction is j cap. So m into 2 j cap, okay? Plus for third particle this is m, and this distance is 2 and direction is I cap. So this is 2 I cap divided by all 3 masses are identical, so it will become 3m. So now I can see that m and m get cancelled. So this is 2 by 3 I cap plus j cap. 2 by 3 I cap plus j cap. So which is the correct option? A, B, C. So B is correct answer. B for Bombay is correct answer, okay? B for Bombay or B for Bangkok. B for Bombay is correct, okay? So this was as this simple, right? So I'm just telling you again, you don't need to worry about physics. The topics are really easy. Just you need to have your confidence. You just go through the concepts very clearly. Don't mug up anything. Try to understand. Just try to learn from the very fundamental concept. Apply the fundamental concept on the problems, and you will love this subject. You will understand it better. Definitely you will score very good marks in physics. Just carry on with this, okay? Yeah. Moving to the next question. Can you just try this question? Can you try this question? I'm giving you 10 seconds of time to think of it. Just take 10 seconds of time and just try solving this question. Okay, so it's my turn to solve this question. Now we have two spherical bodies of mass m and 5m, and radius is r and 2r, are released in free space with an initial separation between the centers equals to 2r. Okay, okay. So this is my situation initially. I'm having one sphere here, and I'm having one sphere here. Like this. So the radius of the first one is r, the radius of the second one is 2r, and it's given that the initial separation between their centers is 12r. So this is r and this is 2r. So it makes what? 3r, and this remaining distance from here to here, this is 9r. Okay, this is 9r. If they attract each other due to the gravitational force only, again coming back to the same concept that we discussed in the first question of today's session, that they are moving only because of the gravitational force of attraction. So this is an internal force. There is an internal force. If I am considering these two spheres as my system, so if I am considering these two spheres as my system, so the force acting between them is the gravitational force, that is the mutual force of attraction. This is the internal force, and there is no external force. External force equals to 0. And when external force equals to 0, then VCM will remain constant, and acceleration of center of mass will become 0. This is the learning from the first question. Now you see, the beauty of this question is what? The very fundamental concepts are being used here. So VCM will be constant, acceleration of the center of mass will be 0. Okay? Yeah. Now they are asking then the distance covered by the smaller body before the collision. So I'll draw one more picture where the two spheres are getting colliding. So this is the smaller sphere and this is the bigger sphere. Okay, this is the situation. So this is r distance and this is 2r distance. This is r and this is 2r. Initially the separation between them was 9r. Now the separation between has become 0. So this has moved by a distance of, let's say, x. This has moved by a distance of x. So this one has moved by a distance of 9r minus x. Okay, this has moved by a distance of 9r minus x, because finally they are colliding, right? So separation between them is 0. Initially the separation was 9r. So if it has moved by a distance of x, then the remaining distance has been covered by the another sphere. So it has covered a distance of 9r minus x. Now we know that the since initially both were at rest, so initially center of mass was having 0 speed and it have to be constant. So it means center of mass remains stationary. Remains stationary. And if center of mass remains stationary, then what I can say is m1x1 m1 dx1 plus m2 dx2 should be equals to 0, right? Means the mass of the first one is m and this is having mass as 5m. So this has traveled a distance of x, so m into x, and that should be equals to 5m multiplied by 9r minus x. Solving this one, I can find out the correct answer. So m and m will get cancelled. So x equals to 9 into 5 is 45r minus 5x. So this is 5x plus x, 6x equals to 45r. Solving it further, x equals to 45r divided by 6. So 3 15 times and this is 2 times. So this is 7.5r. So x value is 7.5r. So the smaller sphere has traveled by a distance of 7.5r. And this is, they are asking us to find the distance covered by the smaller body. The distance covered by the smaller body is x and x value is 7.5r. So 7.5r is the correct answer. The answer is B. I hope this is clear to everyone. So guys, this was all from my side for today's session. So I have taught you the concept of center of mass with some examples, with some questions. You can try more questions based on these topics. You can try more questions based on these concepts, and you will find out yourself to be in a more confident situation as compared to the previous situations. Okay. So if you want some topics to be done in our sessions, you can write down that name of the topic or name of that concept in the comment box, and I'll be more than happy to bring you a session based on your requirement, on your topics in my coming sessions. So till then guys, bye bye. Enjoy learning. Keep putting your sincere efforts. Be disciplined. Exam is approaching, is very nearby. So you have very little amount of time left with you. So do a rigorous revision. Do a rigorous revision. Read from your notes multiple times. Practice questions, and that's all from my side. So guys, bye bye. Take care.